Hello, welcome back. In this segment, I will prove this interesting theorem. Q implies R implies not Q implies not P implies P implies R. We don't know what P, Q, R, three propositions. We don't really care about them from a semantics point of view. But the goal is to prove this implication is true. How do we go about proving it? We will use the proof checker. As we apply our natural deduction rules, we can check whether we are on the right direction or not. We create first Q implies R as the assumption, right? That's the highest level. And then we create another for the next layer of implication. We need one more layer of proof, P, because P implies R is the final one. So we have three layers of subproofs. Okay, the tool doesn't allow me to introduce double knot introduction. There is no such thing called DNI, so I need to use another trick to simulate DNI, which is not a huge problem. Suppose I put not P, okay, as another assumption. And what happens now? Now I have a problem. I have P here and I have not P. That means it's a contradiction. Go ahead and edit the rules. So I need to add a line below this, right? So P and not P is a contradiction. That means we are eliminating a not. That is the rule that we are applying, not from lines 3 and 4. Right? 3 and 4, if you combine, you get a contradiction. That means we're eliminating a not. We talked about eliminating not in one of the natural deduction rules segment. Okay, we have something and it ends with a contradiction. That means the something must be wrong. So we need to negate the something. I can just say negate P, which is because of negation introduction 4 through 5. Let's see whether the proof is on track so far. Any mistakes? Okay, no errors, but you have not reached the conclusion. Okay, so we have not P. Why did we do all of this? Well, from line number 3 to line number 6, we basically saying the same thing. P is same as not P. It's a double not introduction I have achieved. And now I have to think, what is the next thing I need to do? If you now combine line number 2 with line number 6, what can happen? Okay, let's do that. Let's combine line number 2 with line number 6. Can we get something useful? Yeah, we can. That's basically modus tollens, isn't it? We are negating this part. That means we need to negate this part also. So it's not Q because of modus tollens, line 6 and 2. Okay. You can stop the video and think whether this is correct or not. I'll first check the syntactically. It's okay. Yeah, no proofs. And we are also following the rules correctly so far. And now we can easily eliminate double knot using the double knot elimination rule, which we talked about earlier from line number 7. But from Q, we can infer R because of line number 1. So R, we are eliminating the implies by combining line number 8 with line number 1. Okay. We reached R from P. Okay. This is one level up. So we could say P reached R. All right. And we essentially introduced the implication from line number 3 through 9. Yeah, so we introduced the implication. Let's check the proof. What did I make mistake? 2. Where is this mistake? Start from P. I end up with R. Oh, it's not elimination. This is called introduction. I'm introducing. Now I should be able to check the proof. Okay, again, I made a mistake. What is this? Cannot parse justification cites non-existent rule badly formed. Okay, let's check the proof. 8 and 1. From P, we reached R. This is because of implies introduction, line numbers 3 to 9. Yeah, so we are on track so far. And the next thing is we need to copy this. Okay, so from P, we reached R. Similarly, from not Q implies not P, we reached P implies R at one level up. This is implies introduction, line numbers 2 through 10. No errors. Very good. So we are almost there. Now we can copy the root, the highest level formula, add it to this one, and this one we can copy. This is the regular implies we talked about. So we are introducing an implies from line number 1 through 11. You can check the proof. Congratulations, the proof is correct. All right, so that was quite a bit. We start with Q implies R as an assumption, not Q implies not P as another assumption, P as another assumption. We were able to introduce double knot to the P because the tool doesn't have double knot introduction, so I have to go through this not P introduction and show there's a contradiction. Therefore, it must be not P. That's the wrong assumption. So not P allows us to use Modus Tollens. That's the reason I put empty 6, 2. So sixth line combined with second line will give you a not Q. Not Q is same as Q, double not elimination. Since Q implies R, I can come to R here, and then so we start with P, right? And we end up with R, that means P implies R. That is the reason for implies introduction. And similarly, we started with not Q implies not P. We end up with P implies R. That's the reason for this line number 11. And similarly, line number 12 to complete the proof. Okay, that's basically it. Thank you very much.